In this video, we are going to discuss the data transfer schemes we used in 8085. Now, we already know that data is required to be transferred in between the microprocessor as well as into the memory, in between microprocessor and the peripheral devices, and even somehow we are in requirement of transferring the data in between the memory and the peripheral devices. Now, the different types of data transfer scheme is being used just because the capability of the different systems. Since we are using three kinds of devices, one is microprocessor, another is memory, and third one is the peripheral device or the input output device, and the structure of each and every and the process of working of each and every device, such device, is different. As we know that microprocessor is a semiconductor device, memory is also semiconductor device, but the peripheral devices are not semiconductor device. It may be electromechanical device. So, whenever we have to transfer the data in between two devices, if they are working on the same technology, then it will be easy to transfer the data. But if the different devices are working on the different technology, so we have a lot of problem for transferring of the data. That is why data transfer scheme, different schemes are being used for transferring the data. Now, input output devices are available in the wide range of speed. We know that every input output devices has different kinds of structure, different kinds of working, different kinds of pattern, different kinds of speed. So, and it has different characteristics also. So, we are in requirement of certain interfacing, because there is a difficulty in between the transferring of the data in between the processor and the input output devices. So, we used to design certain interfacing circuit for that particular purpose, and that the work of that interfacing circuit is to easily transfer the data in between the processor and the peripheral devices. Now, what is the interfacing circuit? It is the logic circuits along with certain instructions that enables the microprocessor to communicate between the processor as well as the peripheral devices. So, those devices which are made up of logic circuits along with software, that is the logical instruction, which helps in communication in between the processor and the peripheral devices, are known as interfacing devices. Now, as far as we already know that the processor is having its own speed, memory is working on the different speed, and the input output devices are working on a different speed. So, two broad categories has been imposed, has been used because of the speed mismatch in between the processor and the input output devices. So, these two broad categories are program data transfer scheme and the DMA data transfer scheme. Now, program data transfer scheme is a such kind of a scheme in which certain program is being used for transferring of the data, and it is under the control of the processor itself. But second scheme is the DMA data transfer scheme, in which processor is not under the control of the actual transfer of the data, but DMA data transfer is a kind of a transfer scheme which is controlled by the peripheral devices. You can say that there is need of another controller by which we are able to transfer the data. Now, as far as the program data transfer scheme is concerned, it is used for transferring of the smaller amount of the data, but DMA data transfer scheme is used for the transferring of the data in between the two devices, as well as the large amount of the data has to be transferred. So, in case of program data transfer, let us discuss the program data transfer scheme, which is controlled by the central processing unit or the microprocessor itself, and all the data transfer took place under the control of the program which resides in the memory. So, it is the program which is taking the control for transferring of the data. Now, these programs are executed by the processor itself, and it is executed when the peripheral devices are ready to transfer the data, because it may be, as I told you, that peripheral devices are not so fast as the processor, because when the processor is in requirement of certain data, it is not necessary that it will be available to the to the peripheral device, or when the peripheral device wants to transfer the data, the processor will be ready to receive it, but it has to inform that they want to transfer the data. So, because of the mismatch of the speed, we need certain type of program by which we can transfer the data. As I told you, it is used for a small amount of the data if we want to transfer. Now, the three categories comes under this program data transfer scheme, that is synchronous data transfer scheme, asynchronous data transfer scheme, and the interrupt data transfer scheme. Now, as for the synchronous data transfer scheme means, synchronous means at the same time, means the transmitter and the receiver are synchronized with the same clock, meaning that by the time when processor wants to transfer the data to any device, or the device wants to transfer the data, both the device, peripheral device wants to transfer data to the processor. So, both devices must be ready to send the data or the receive the data at the same time. Asynchronous data transfer scheme means at a different time. Synchronous means same time. Asynchronous means at the different time. And another scheme is that is interrupt driven data transfer, in which since the peripheral devices are slow, whenever the data is available to the peripheral device and it wants to transfer the data, it gives the signal to the microprocessor, giving the information that it wants to transfer the data, and so in the form of a request signal they use to interrupt the process of the processor. So, whenever processor receives that kind of interrupt from the peripheral device, it understands that device is ready for transferring of the data. So, whatever it is doing, it will stop temporarily, and then actual data transfer took place, and then processor resumes its first. Now, as far as the DMA data transfer scheme is concerned, CPU does not participate in this kind of a scheme, because the controller which is used for implementation of the DMA data transfer schemes, it informs the processor that we want to transfer the data in between the two different devices. So, please whatever control of yours, means the processor control on the address and the data bus, please release that control, and it comes under the control of the controlling device, and then it transfer the data. So, with the help of DMA data transfer scheme, the data is directly transferred in between the two memory, or the in between memory and the peripheral device, or peripheral device and the memory. So, it is controlled by the DMA controller. So, that is why the difference in between program data transfer and DMA data transfer is, the main difference is program data transfer scheme is controlled by the processor, and the DMA data transfer is controlled by the controller. And for this particular process, to implement the DMA data transfer scheme, it uses two signals, hold signal and the hold acknowledge signal. Now, as far as this diagram is concerned, it is just giving you the information that the actual data take place in between the processor and the memory or the input output devices. It requires certain address bus, data bus, as well as the control bus. We know the address bus is used to carry the address. If the processor wants to transfer the data to the input output device, it is the device address which has to be sent on the address bus. The actual data is being carried from the processor through the data bus to the peripheral device, and it is the control signal which is carried by the control bus to give the information that what kind of operation it is going to be performed, whether it is a read operation, whether it is a write operation, whether it is input output read operation, whether it is memory read operation. So, that is, so basically these three buses are the main constituent of in actual transfer of the data. Now, this is the total scheme. You can say that this diagram is showing that different kinds of data transfer scheme which is used in 8085 depending upon certain parameters, and based on that parameter it has been categorized. So, the first parameter is the transmission format. Now, as far as the transmission format is concerned, the data transfer scheme is divided in two parts. One is asynchronous, another is synchronous. I have already told you synchronous means at the same time, means both the devices will be ready to transfer the data at the same time, and it is possible only when both the devices are working on the same technology as well as the same structure or the same speed. And asynchronous means the irregular interval, The synchronous irregular intervals means whenever data is being transferred from one device to one processor to the device or from device to the processor, whenever it is being sent, it is received at the next time. So, there is no matching of there is no synchronization at all, there is mismatching of the speed. That is why the two transmission formats are used. So, synchronous is used whenever the two devices which are working on the same speed, but asynchronous scheme is being used when the two devices are working at a different speed. So, synchronous is used for the high speed data transfer and asynchronous is used for the low data bit transfer, low speed data transmission. Now, the data transfer between the processor and the peripherals are primarily asynchronous. Very rarely we use the synchronous data transfer scheme because of the mismatch of the speed. Now, the second one is the mode of data transfer, that is parallel or serial. There are many peripheral devices which can send or accept the data in parallel fashion, either in the form of a 4-bit or in the form of a 8-bit. So, whenever we are transferring the data in the form of a 8-bit or 4-bit, that is called parallel data transfer. And whenever there are certain devices which does not transfer the data in parallel, they used to transfer the data in serial mode only, and that for that particular we will be using the serial data transfer. So, depending upon the mode of the data transfer, it can be categorized in the parallel data transfer or the serial data transfer. In the serial data transfer, only one bit is being transferred at a time. Data are transferred one bit at a time over a single line between the processor and the peripheral, and for data transmission, the processor to a peripheral, a word is converted into a stream of 8-bit, and this is called parallel to serial conversion. Now, a stream of 8-bit is converted into a parallel word. This is called serial to parallel. So, the serial input output mode is very commonly used with the peripherals such as CRT monitor, printer, input output, cassette tape, like that. Now, the third category on which the data transfer scheme is being categorized, that is type of input output. Now, there are two categories of this. One is peripheral mapped input output and second one is memory mapped input output. Now, what is peripheral mapped input output and what is memory mapped input output? In case of peripheral mapped input output, all the peripheral devices or all the input output devices are considered to be a separate entity. Separate entity means they have their own significance, they have their own physical existence, and it is considered to be separate from the memory. And that is why for that particular purpose we will be using in instruction or the out instruction for communicating in between the processor and the peripheral devices. So, in instruction is used to receive the data from the input device to the microprocessor, and out instruction is used to give the data from the processor to the output device. But in other hand, in case of memory mapped input output, all the peripheral devices connected to the microprocessor unit are considered to be the part of the memory. So, it works like a memory, it is considered that they are working as a memory. So, in this case, all the instructions which are used to transfer the data in between processor and the memory, the same instruction is used for transferring of the data in between the processor as well as the input output devices. They have no separate identity, they have no separate physical existence. It is considered to be the part of input output, and that is why in that particular case, if input output devices are memory mapped, then it means all the instructions which are used for memory data transfer will be used, such as LDA, STA, LDAX, STX. Now, one more thing, in case of peripheral input output device, all the input output devices are considered to be separate entity. So, the addressing scheme which will be used in case of peripheral mapped input output, we will be using only 8-bit address for addressing the input and the output devices. But whenever a peripheral devices are considered to be memory mapped input output, then in that case the address of the individual input output devices are considered to be a 16-bit, and that is why we will be using the all memory operations, all memory instructions which are used for the data transfer with the peripheral devices also. Now, the next category is condition of the data transfer. In condition of data transfer, we have another two categories. One is microprocessor control and another is device control. Now, microprocessor control data transfer scheme is such a scheme in which the controlling power is given to the processor itself, and all the instructions will be used for transferring of the data. We already know that as I have discussed that address bus, data bus and the control bus, these three buses are very important for the transferring of the data. Now, as far as the microprocessor control is concerned, every time all these buses which are available in the microprocessor, it is under the control of the microprocessor. So, most of the time whenever you want to transfer the data from a one memory device to another memory device, what you have to do? You have to copy the data from the one memory device, source memory device to the processor, and from the processor to the another destination memory. But since this process is very tedious process, very time taking process, so we used to avoid this process whenever we have to transfer a large amount of the data, because it will take too much time to transfer the data from the source memory or source to the processor and then from processor to the destination. So, that means it is under the control of the microprocessor. So, all those schemes which transfer the data in between processor and the peripheral, which are under the control of the microprocessor, comes under the category of the microprocessor control. But there is another scheme which is called DMA, that is direct memory access data transfer scheme, which is controlled not by the processor but by the device controller itself. So, in that particular case, the device controller asks the microprocessor to release its control over the address bus, data bus and the control bus, so that it will take care of that. It will take the control of all these buses, and then it allows to transfer the data in between the two different memory or the two different devices, or in between memory and the devices, or devices or the memory. So, based on this category, it has been categorized as microprocessor control or the device control. Now, microprocessor controlled is again categorized into 5 different categories, and the first category is the unconditional. Now, in this form of the data transfer, the microprocessor assumes that the peripheral is always available, and it transfers the data. So, there is no need to check the condition whether the device is ready or not. For example, if you take the example of a CRT screen, if you take the example of LED port, microprocessor simply enables the port and transfers the data and goes on and resumes its work. It does not wait that whether it is going to display or not. So, that is the unconditional data transfer. The second one is data transfer with the pooling. Pooling actually means to check the status. Pooling means status check. Now, in this form of the data transfer, the microprocessor is kept in a loop to check whether the data is available or not, whether the device is ready or not, whether the data is available or not. So, this is called pooling. So, microprocessor remains always busy to check the peripheral device whether the data is ready or not. So, the timing of the processor is going to be elapsed just in checking whether the data is available or not. So, you can take an example that the processor wants to read certain data from the keyboard. So, what it will do, keep on pooling, keep on checking whether the key has been pressed or not, key has been pressed or not. The third scheme is the data transfer with the interrupt. Now, data transfer with the interrupt 8085 or any processor allows any devices to interrupt the process of the processor and then transfer the data. So, that type of scheme is known as interrupt driven data transfer. So, in this condition, when a peripheral device is ready to transfer the data, it sends an interrupt signal to the processor. The processor stops whatever it is doing, current execution of the program. It executes the current program, whatever it is doing, and then it returns, it handles the peripheral device which has interrupted. And since the device has interrupted the processor working just to transfer the data, so actual data transfer took place just because the microprocessor has been halted by the interruption, and after the data transfer is over, the processor resumes its work. So, in this interrupt technique, the processor is free to perform the other tasks, rather in the case of, in comparison to the pooling. In case of pooling, it keeps on checking, but in case of interrupt, it does not keep checking. Whenever it receives any information that it has been interrupted, it came to know that the data is ready and the data is being transferred. The next one is data transfer with the ready signal. When the peripheral devices or the memory devices are slower than the microprocessor as far as the speed is concerned, the ready signal is used to add additional time, or you can say T state, for extending the execution time. So, this process provides sufficient time for the peripheral to complete the data transfer. The technique is normally used for the slower memory chips. Whenever memory chip which is available with the microprocessor is slower, it informs by sending a ready signal to the processor, and processor came to know that the device is now ready to transfer the data. The next one is data transfer with the handshake signal, in which signal being exchanged in between the peripheral device and the processor, and it is called handshake signal because we know that for handshake we require two hands. So, if the device is ready to transfer the data, it sends a request signal to the processor, and processor acknowledges by sending an acknowledge signal to the device, or when the processor is ready to accept the data, it informs the peripheral device that it wants the data, and when the device will become ready, it will send an information in the form of acknowledgement to the processor. So, a kind of two signal being exchanged in between the processor and the peripheral device before the actual data transfer took place. That is why this kind of scheme is known as data transfer scheme with the handshake signal. Now, this handshake signal is again divided into two parts. One is status check, another is interrupt. Now, in the case of status, the status check method is functioning very much similar to the pooling method and achieves the same result, and interrupt will be using the same method as I have already informed in the case of interrupt driven data transfer. And I have already explained the peripheral control data transfer scheme using hold signal and the hold acknowledge signal and so on. So, let us discuss more detail about the synchronous data transfer. Synchronous means that at the same time, and this scheme is employed when both the device are compatible enough to transfer the data at the same time. And asynchronous means the irregular time or different time when the speed is not going to match. Now, asynchronous data transfer, an example has been shown to you that microprocessor is in requirement of certain data, and suppose the peripheral device is analog to digital converted. So, it sends a message to start the conversion. AD converter is a kind of a device which converts the analog signal into digital signal. So, whenever it receives any information from the processor, it starts conversion, and when the conversion is over, analog is converted into digital, it sends a signal to the processor that it is over, now you can transfer the data. So, this is asynchronous data transfer, because at a particular moment of time microprocessor is ready to have the data, but the data is ready available after certain time from the AD converter. So, this is asynchronous. Now, I have already explained the mode of the data transfer, in which we have parallel mode and the serial mode. Parallel mode means 4 bit, 8 bit, 16 bit at a time. Serial mode 1 bit at a time. I have also given the idea of input output mapped and memory mapped input output, in which input output mapped input output is considered to be separate entity. In memory mapped, all the input output devices are considered to be a type of memory. This is also explained. Now, as far as the microprocessor control is concerned, it is also explained that unconditional means no condition has to be checked. It is considered that it is always available, and the pooling means that status checking. Interrupt means any device wants to transfer the data, can interrupt the processor. Slower peripheral devices, slower memory devices can use the ready signal, and the kind of a scheme in which two signals are being exchanged, that is the handshake signal. And this is the example of an interrupt driven data transfer, in which when the device is ready to transfer data, it sends an interrupt signal to the processor. So, then it is being transferred. Now, as far as direct memory access data transfer control is concerned, or peripheral control data transfer is concerned, it uses the scheme DMA, in which it will be using hold signal and the HLDA signal. Whenever controller wants to have a control over the address bus, data bus, which is under the control of processor, and wants to take the control, it sends a hold signal high to the processor, and processor whatever it is doing, it will stop and gives the control by sending the hold acknowledge signal. So, data are transferred with a very high speed without any intervention of microprocessor, and the data is being transferred from source to destination, and there is no role of microprocessor at all. Now, it works in two modes. One is burst mode and in the cycle steering technique that we will explain later on when we will be discussing more about the DMA. So, since in case of peripheral control data transfer scheme, the total control is up to the input output devices. So, that controller must have its own register, counter, as well as it is able to generate the control signal, so that it will be able to transfer the data. So, that is all about the different data transfer scheme which is used in 8085.